Hi everyone, today we're going to be finding nth roots of numbers and solving equations using nth roots. Let's keep in mind that the square root of a number a is a number c, such that c squared equals a. Remember, square roots and squaring are inverse operations. Example 1 says find all square roots. Find all the square roots of 196. So when I'm finding all the square roots of 196, I have to think about what number squared would give me 196. Okay. So it asked me to find all square roots of 196. I think about what numbers, when I square them, would give me 196. It's going to have to be a number bigger than 10 because 10 squared is 100. So that's not quite to 196. I know 12 squared is 144. So maybe we'll start with 13 squared. That's 169. And 14 squared is 196. Okay, so 14 is going to be one of the roots. Is there anything else that when I multiply it by itself or when I square it would give me 196? Well, what about negative 14 when I square that? See, I still get 196. So I could say 14 or negative 14. Both of those would work in this case. Okay, be careful how you put it into your calculator, because if you put it into your calculator like this, you're going to see you don't get positive 196. Right now, with order of operations, it would be squaring the 14 first and then multiplying by negative 1. Okay, so you want to make sure that you're putting whatever number you're squaring inside parentheses. What about finding the roots of 289, square roots of 289? Well, we already know that 14 squared is 196. So it's going to have to be a number bigger than that. Maybe we'll try like 17 squared. Oh my gosh, that worked, 289. Okay, so I'm going to say 17 is a square root of 289. Again, that's because 17 squared is 289. That's why I can say that. Also, negative 17 would work as well, right? I'm still going to get 289. This symbol right here is asking you for the principal root. So whenever you see that symbol, it's a little bit different than what we just did in example 1. You're only going to want to list the positive answer. Okay, that symbol is called a radical sign. It says the radicand is the expression written under the radical. Okay, so here it says solve an equation for all roots versus finding the principal root. Okay, again, whenever you're asked for all the roots, you might have more than one solution, versus if I'm asked for the principal root, I'm only going to have one answer. Okay, I'm going to say all roots. I'm going to put could be more than one. Whereas a principal root, we're just going to have one, so just one. Okay, so solve here. I'm square rooting both sides. I would get x equals plus or minus 4. Again, anytime you draw on the square root yourself, you got to put plus or minus. So this would be an example where I'm listing all the roots, where I'm getting more than one solution. In part B, notice that I didn't have to draw in the symbol myself. See how the symbol, the radical, is already drawn in for me? In that case, I'd be looking for the principal root. So what is the square root of 36? It's going to be 6, and then I bring down the negative out front, and that's my answer. In this case, I would not put plus or minus 6. Okay? It's just looking for the principal root because the symbol was already drawn in for us. In part C, what do you think's happening? Are you drawing in the symbol, or is it already given to you? You're drawing in the radical sign. Okay, so because I'm taking an even root on both sides, I'm going to put that plus or minus. The square root of 81 is 9, and the square root of 100 is 10. Again, this is a situation where we're listing all of the roots. Last but not least, again, I'm given the symbol this time. So if I'm given the symbol, I'm only going to have one answer. Okay, so let's think. What is the square root of 64? That would be 8. So I have to do some kind of decimal with 8 in order to get 0.0064. So if I do 0.8 times 0.8, that gets me 0.64, not 0.0064. So let's add in the 0. There we go. We get 0.0064, right? Another way that you could do it is by squaring it to get the 0.0064. Notice that when I have 1 0 after the decimal and then times itself, do you see how I have 2 after the decimal here? Okay, so just look for those patterns. My simplification is just going to be 0.08. I'm not going to put plus or minus. Okay, and the reason why I'm not putting plus or minus is because this radical symbol was here before. I did not draw it in myself, so that's how I know I'm just looking for the principal root. Okay, down here it says you can extend the concept of a square root to other types of roots. 2 is a cube root of 8 because 2 cubed is 8. In general, for an integer n greater than 1, if b to the nth power is equal to a, then b is an nth root of a. An nth root of a is written as the nth root of a. It looks like this. It says where n is the index of the radical. Okay, and I'm pretty sure that this is a problem on your homework where you have to fill in a blank. It says for an integer greater than 1, if b to the nth power equals a, then b is an nth root of a. I'm pretty sure that is on your homework, so you might want to highlight that. Just talking about some vocabulary here. Your index is your root. Okay, so another name for index is your root. Okay, your radicand is just what is underneath the radical. So whatever's underneath the radical is called your radicand. And then the actual symbol is called your radical sign. Okay, so you could have square roots, cube roots, fourth roots, fifth roots, etc. All right, down here it says real nth roots of a. Okay, so we're talking about an nth root of a. So it looks like this, nth root of a. So a is your radicand and n is your root. It says if a is less than 0 or if a is negative, then there are no real nth roots. Well, that's true. Let's look at this example down here. Do you see how I'm taking the square root of -4? As soon as I see the negative, I know there's going to be an I that comes out. And then what's the square root of 4? 2. So this would be 2i would be my answer. See how there's no real nth roots? Okay, that makes sense. So when n is even, like in this case, my root was a square root, right? And I have a negative radicand, then I'm going to get no real solution. Okay, what happens if my a value is 0 under that even root? Well, the square root of 0 is 0, right? This is an even root with a radicand of 0, and I get 0. Okay, what about if a is positive? It says we're supposed to have 2 real nth roots. Well, I know that the square root of 4 is 2, right? If this symbol was written in for us, then I know I'd be looking for the principal root. But, here's a big but if the question is asking for all roots, then the answer would be 2 and -2 because 2 squared is 4 and -2 squared is 4. So it's all depending on how the question's set up. If the question's set up with the radical in the original question, you just put the one answer. But if it's asking for all roots, then you're going to have to look to see if you need to write more than one. Okay, the only time you're going to ever have to write more than one root is if n is an even integer and a is bigger than 0. Then that's going to be when you are going to have 2 of those real nth roots. All right, going over to odd, right? So now n is an odd integer. What happens if a is less than 0? Well, notice I have an odd root now, right? It's a cube root. And my radicand is less than 0. What would that simplify to? That would be -2, okay? And that's because -2 times -2 times -2 would be -8, okay? Or you could say -2 cubed is -8. All right, what is the cube root of 0? Well, that's going to just be 0. right? Because 0 cubed is 0. And what's the cube root of 8? Well, that's going to be 2. Okay, and that's because 2 cubed is equal to 8. Now, in this case, why would I not have two solutions? Like over here, when a was bigger than 0, I had 2 real roots. Over here, when I have an odd root, why is it that I only have 1 real root? Let's investigate that. What happens if I use -2? Like if I were to cube -2, what would I get? I would get -8, not +8, right? So I'm not going to list two solutions. There's still only going to be 1 real root. And I just went ahead and erased that so I could actually write real root. Okay. So anytime, just a summary, just looking back at here, anytime you see that your root is odd, you should be thinking that you're going to have 1 solution. It's when the root is even that it's going to vary. It could either be none, 1, or 2. Okay, so a little bit confusing there, but we just think through it and it'll all be all right. Okay. So let's go to the next page where we're actually finding the nth roots. We'll start over here. Okay, remember, we're thinking about the nth root of a. So in this case, n is 3. So we're thinking of a cube root, and we've got -216. Okay, and the question's asking us to find the indicated real nth roots. Okay, so we're not given the radical symbol. So if it's possible that we could have more than one answer. Okay, so here if I've got the cube root of -216, that's going to be what? Well, I'm just thinking about what times itself 3 times get me to 216, and that would be 6. And then in order to get -216, I'd have to use -6, right? -6 cubed would be -216. Okay, so that would be it. It's just -6. +6 wouldn't work, right? If I cube +6, that would be +216. Okay, so that's not going to work. Here we've got a 4th root. Ooh, those even roots. Be careful. Even roots are tricky. And we've got 81, which is a positive radicand. So this is a case where we might have more than one solution. Okay, the 4th root of 81. I'm thinking something times itself 4 times would give me 81. I think that's 3. Let's try it. Is 3 to the 4th 81? Let me type that into my calculator, and it is. Okay. Now, would -3 to the 4th power also work to give you 81? Yes, it would. As long as you put that in parentheses, the -3 in parentheses, then you do get 81. So I'm going to say 3 and -3. Okay, that's the one you got to watch out for, is when the root is even and the a value is positive. That's when you could have more than one root. Okay, here we've got a square root. I don't need to put the 2 here. If I just leave that blank, it's implied that it's a square root. Okay, and my a value is 0. So what is the square root of 0? Just 0, 1 solution. Okay, here we've got a 4th root, and it's 16. Ooh, here's another one, right? N is even, and my a value is positive. Okay, so I have to be careful with this. The 4th root of 16, let's see, I think 2 to the 4th is 16, and it is, right? 2 times itself 4 times is 16. But what else could get me to 16? Couldn't -2 to the 4th also get me to 16? Yes, so I'm going to say 2 and -2. Okay, both of those work in this case. All right, then I've got the square root of -49. Uh-oh, I've got a negative under a root. How many real solutions do I have? This is going to be a case where we have no real roots. Okay, we do have an imaginary root. We could say 7i would be an imaginary root, but there's going to be no real roots. So we'll just leave it as no real roots. Okay, so now we get to solving equations using nth roots. It says to solve an equation of the form u to the nth power equals d, where u is an expression, you have to take the nth root on each side. Okay. So we're going to isolate the expression that's being raised to the nth power, and then we're going to take the nth root on each side and simplify. Don't forget plus or minus for even roots. I want you to mark that up. Don't forget plus or minus for even roots. For what kind of roots? For even roots. For what kind of roots? For even roots. Okay, circle star that. We don't need plus or minus for odd roots. Well, why is that? Let's go back up here. Okay, remember that for even roots, that's when we need to worry about possibly having more than one answer. Okay, for odd roots, notice that all the time we just have the one real solution. We're not going to worry about plus or minus for odd roots. Okay, so over here, we're going to start by getting the x to the fifth isolated. So I'm going to divide both sides by 4. So what is that? What is 128 divided by 4? It's going to be 32. Then how do I undo a fifth power? What is the inverse of raising something to the fifth power? The inverse of that would be taking the fifth root. The fifth root undoes the fifth power, and it just leaves me with x. Whatever I do to one side, I have to do to the other side. So I'm going to use the fifth power over here. Okay. Now, do I need a plus or minus? No. No plus minus needed because it's an odd root. Okay, so what is the fifth root of 32? What to the fifth power is 32? I think that's 2 to the fifth power. Yeah, 2 to the fifth power is 32, so x would equal 2. All right, in part B, we need to isolate this x squared. So I'm going to start by subtracting 1 on both sides. We get 2x squared equals 8. Divide both sides by 2. We get x squared equals 4. We square root both sides, and we get x equals 2, right? No, I need plus or minus. How did I know I needed plus or minus? It was because it was an even root, and I was writing the symbol in myself, right? Anytime you are physically drawing in that radical symbol that wasn't there before, you need to put a plus or minus for those even roots, okay? Even though over here we drew in the radical symbol ourselves, we did not need the plus or minus because that root was an odd root. Okay, you only need to put plus or minus if you've got an even root and you're drawing in that symbol yourself. Okay, plus or minus with even roots where you draw the radical sign or the radical symbol. Okay. Part C, what's being raised to the fourth power? X minus 3 is being raised to the fourth power. Okay, so that's already isolated. What is the inverse of raising something to the fourth power? Well, that's going to be taking the fourth root. Okay, you want your power to match your root. Then they're inverses. Okay, the fourth root undoes the fourth power, and it leaves me with x minus 3. On the right-hand side, do I need plus or minus? Yes, because it's an even root that I drew in myself. Okay, to finish getting x by itself, we'd add 3 to both sides. So we'll get 3 plus or minus the fourth root of 21. And I don't think 21 is divisible by any perfect fourths. 1 to the fourth is 1. 2 to the fourth would be what? 2 to the fourth power is 16. 21 is not divisible by 16. 3 to the fourth power would be 81. Okay, so 21 is not divisible by any perfect fourths except for 1. So we'll just leave our answer like this. All right, in part D, I'm going to start by getting x cubed by itself. Right now it's being divided by 4. So to get it by itself, I'm going to be multiplying both sides by 4. Whatever I do to one side, I have to do to the other side. So we get x cubed equals 40. Okay, what is the opposite of cubing something? Cube rooting it is going to be the opposite. Okay, so let's go ahead and cube root both sides. We get x, right? Because the cube root undoes the cube power, equals, do I need plus or minus? Nope, don't need plus or minus because it's an odd root. Okay, let's see if I can simplify this at all. What are my perfect cubes? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is what? I think it's 64, right? So 40 falls in between that. So is 40 divisible by 27? No. 8. Yes, it is divisible by 8. 8 times what is 40? 5. Okay, where 8's perfect. So I'll simplify the perfect part. What is the cube root of 8? The cube root of 8, see, whoop, it would be 2. So I'm going to write 2 cube root of 5 as my answer. Okay. And I think that's it for the notes. I just think that it's really important that we understand that if you have a number squared, you should square root to undo it. If we have a number cubed, what should you do? Cube root it. If we have a number to the fourth, what should you do? Fourth root it. Okay? If we have a number to the fifth, what should we do to undo that operation? Fifth root it. Okay? They're inverse operations. They undo each other. Anytime we have an even root, you need the plus or minus. So like, I'll just highlight them. For the squared, right, when we square root, we need plus or minus. For the fourth power, when we fourth root, we need plus or minus. Okay, it's anytime we have those even roots that you'll need to put in the plus or minus when you're solving those equations. Okay, another reminder, if you are drawing the radical in yourself for the even roots, then you do plus or minus. If the radical is already provided to you, right, if it's already in the problem, then you don't.